Okay, is that okay? Hi, everybody. My name is Ciaran Regan, and I'm going to be actually presenting two talks today. So I'm this one, and the next one is also my paper. So if it's okay with the chair, I'd like to just continue it one after the other. Thank you very much. So, cool. So I'm going to talk a bit about generative agents and their applications. So it's not purely agent-based modeling that I'll be presenting on today. So I hope you can bear with me. The first work is titled Capturing Individuals' Communication Styles Using Large Language Models. So this was work in collaboration with Gaudi Inc. in Japan and our lab at the University of Tsukuba. So I wanted to talk first about some research that's going into realizing autonomous agents. So this is the kind of seminal work, generative agents, interactive simulacra of human behavior, which I'm sure many of you already know. I think it was discussed already today. But in this research, they have different agents which are powered by large language models. Each agent is given its own kind of unique personality and traits, as well as its daily habits, what it carries out every day, what's its job, what's its hobbies, and then in the world, it carries out these tasks autonomously. So I've actually prepared a video. This is four agents who are instructed to be AI researchers, and they go about their day. So I'll play that. And so first they wake up and they cook breakfast. And then after they cook breakfast, they start preparing, as researchers typically do. They send some emails. Then they go outside and they meet each other and they start talking. And then they all go to the library. And then inside the library, they're all talking about their research. And so this is occurring because they were instructed that their habit is they work as a researcher and they go to the library. So they can autonomously go and actually do their work. And then we see them like going for lunch and that kind of thing. And this kind of setup has seen some really interesting emergent behaviors. So one example is the agents were instructed to organize a Valentine's Day party. And one agent was able to diffuse that information to many other agents in the system. And then those agents invited other agents to the party. And then finally, on the day of the party, all the agents showed up in the house and they had their little party. So this is just one really interesting example of kind of emergent behaviors in these systems. And kind of this is made possible by two features. So the first is that large language models encode a wide range of human behavior from their training data. So they kind of know how humans tend to behave, how they speak. And so this is really important. And the second part is the kind of agent architecture that was introduced in this work. So agents perceive events in natural language, and upon perception, they store this event as a memory in their memory stream. And then in the future, they're going to pull back these memories from their memory stream and use them to plan their next actions. Yeah, and then after a few memories, they're going to reflect on their past events. So the purpose here of reflection is that during the course of the agent's life, it's going to observe many behaviors, many very simplistic events like eating breakfast, going to the library. The point of reflection here is to take many events of going to the library and studying and elevate that into, okay, this person is really hardworking. This person really values like studying and that kind of thing. So reflection here elevates and yeah. So can these generative LLM agents actually integrate with our society? So I'm going to talk about a few of the applications in this space so far. So really recently, Andrej Karpathy from OpenAI and Tesla AI and Twitter, among other things. How can we approach an ideal experience for learning something new? In the case of physics, one could imagine working through a very high quality course material together with Feynman, who is there to guide you through every step of the way. So the idea is we're going to use agent architectures like this to build teaching assistants that can kind of power and help people to learn better in the future. Another example is using these kind of agents in decision-making processes. So the CEO of Gaudi Inc. in Japan has actually built a digital avatar, and the staff at Gaudi can use this avatar to communicate directly with the CEO. And anything the CEO says, apparently, uh, they have to take it as his actual word. So this is very interesting, I thought. And then social interactions. So a lot of these kind of AI avatars are being used now for many social situations. So, for example, Bumble wants to let AI dating concierge do the dating for you. So the idea is you'll have your avatar go on a date with another avatar, and then if you're compatible, then you can actually meet in the real world. So then back to kind of the research that we were doing, how can we capture an actual communication style of the individual? So prior studies have been trying to mimic individuals by fine tuning large language models on a large corpus of their text data. But we wanted to propose an architecture where we don't have to actually fine tune a language model. We can do it through prompting. And the kind of goal was for Gaudi to build this application where, kind of like the Bumble example, you can have an avatar that will make friends with other avatars, and then you can actually become friends with the individual. So there's two steps in the avatar kind of process. The first is avatar creation, and it's very much inspired by the generative agents paper. So the first step is to look for any data that the person has written. So if the person writes articles or blogs online, they're going to take this data. And additionally, they designed a interview agent bot. So the individual you want to make an avatar with will communicate with this GPT-4 chatbot and will kind of gather this text on how they actually like to speak. And then we take all this text and we use another large language model to extract features about that communication style. So these features are things like the frequencies of emoji usage, catchphrases that people use, sentence final particles, and tone. And in particular, this is kind of Japanese focused. So things like tone specifically refers to using formal language or informal language. And sentence final particles actually appear quite a lot in Japanese. So these were kind of important in this work. Then the conversations that were had with the agent avatar are summarized and stored as a long-term memory for the agent. So this long-term memory acts as the memory retrieval from the original generative agents paper. Then when the user actually interacts with an avatar, the avatar receives a message, and then it takes its features that were previously extracted, as well as its long-term memories and its short-term memories, and use that to construct a response. And after each conversation, the chats are summarized and elevated into the long-term memory for later use. So then, can this architecture accurately portray individuals? So to kind of address this, we proposed two research questions. Can an individual's communication characteristics be extracted, can be estimated based on the LLM's features? So can the LLM actually understand and extract the features from the text corpus? So to understand this, we collected 50 messages from 30 different individuals, and we extracted the features such as their tone. And then we performed a MANOVA test to see if these features were actually significant. So what we found is a low Wilks lambda, which was indicating that there was an actual statistical difference extracted by the large language model. And in particular, on the right, we see the effect size of each feature extracted. So it turns out that things like the use of emojis and the tendency to use long sentences was quite powerful in differentiating different individuals. Then the second research question was, can the avatars built from these features accurately represent the individuals they want to portray? So to understand this, we took two human individuals and created avatars for them using the method described. Then we got data from both the human and the avatar and compared their responses. So to do that, we took the data and extracted the features and compare the features. In particular, each feature was converted into a numerical score. So it was a binary value like does the individual use lots of emojis or not, was yes or no, and then averaged over all of the messages. And what we found was that there was some aspects, so some features were able to be easily captured by the large language model. So one example is the frequency of emoji. So the large language model was actually able to understand that this person doesn't like to use emojis, and the avatar built from the individual was able to also not use emojis. But some features were actually less well represented. So, for example, the tone in individual A on the left side here, in orange and green, we can see they're quite similar. So both the human and the avatar had a very similar tone or tendency to use formal language. But for the other individual, the tone was way off. So the avatar was using a very different tone. And we believe that this is because individual A was using formal language and the LLM was very capable of repeating formal language, while the other individual tend to speak informally. And the large language model that's been fine tuned to speak respectfully wasn't able to really respond in an informal way. So the kind of results were showing that the architecture is able to capture some of the features in representing individuals, but future research should address some of the issues like testing other LLMs to try and get over the issues with the tone, and also refining the list of features. So the features we selected were, I guess, somewhat arbitrary. So you could imagine refining these features in future work. So next, I'm going to talk about another architecture. Is there any questions so far I can ask?
We're taking questions. Yeah, but I think we can give you a round of applause for the first one.